We are further doing one more colligative properties. We have been learning that colligative properties depends on the number of solute particles in solution and they do not depend on the nature of the particles. So we also know that there are four colligative properties: vapor pressure lowering, boiling point elevation, and the third one is the freezing point lowering, or we can call it as freezing point depression also, and the fourth one, osmotic pressure. So, and the formula for each one is also given over there, but this video is going to focus on freezing point lowering, which is equal to delta TF equals IKFM. Before proceeding further, we will talk something about the vanthoff factor I, which was there in the formula. I is actually equal to the number of particles in solution after dissociation divided by the number of formula units initially dissolved in solution. So what I mean by this, in the table over there, I've given few examples. Sucrose, the number of actual particle is 1 and number of formula unit is also 1. Sucrose is a covalent compound, it doesn't dissociate, therefore the number of particles I see in the solution is 1. But take for the example as sodium chloride, you know it dissociates into two ions, sodium plus and Cl minus, and hence one sodium chloride molecule will give me 2 particles in solution. And calcium chloride I have 3, FeCl3 I have 4, and hence I is a vanthoff factor which has to be taken into account in colligative properties, because we just now learned that colligative properties depend on the number of particles in solution. We will do one question on freezing point depression. Calculate the freezing point of a solution made from 26 gram of calcium chloride dissolved in 950 milliliter of water. Kf for water is given, and the density of water they ask you to assume as 1 grams per milliliter. And the formula for freezing point depression is delta TF is equal to IKFM. So this is a question in which they have asked you to calculate the new freezing point. So if we calculate the freezing point depression, I'll be able to get the new freezing point because we know the freezing point of water. So in order to calculate delta TF, we need to calculate the molality M. And the definition of molality, moles of solute by kilogram of solvent, and moles of calcium chloride can be calculated from the mass given and the molar mass. And then as the density of water is given as 1, the volume of water and mass of water is the same, and hence molality becomes equal to 0.246 molal. And once I get the molality, calculate the freezing point depression using the formula, and the freezing point depression comes as 1.37 degrees Celsius. So freezing point depression or lowering, that means the freezing point has decreased. So if initially the freezing point of water is 0, and therefore take away 1.37 from that, and therefore the freezing point of water will be now negative 1.37 degrees Celsius. A solution is prepared by dissolving 38 grams of toluene in 850 grams of benzene. The freezing point depression was 2.5 degrees Celsius. Calculate the molar mass of toluene. Kf of benzene is given. So benzene is the solvent and toluene is the solute, and they have asked you to calculate the molar mass of the solute. So the steps involved in this question will be: first, calculate the molality of toluene using the freezing point depression equation. And the second one is, after you calculate the molality, get the moles of toluene. We know the formula for it. Moles, molality formula, how is it related to moles? Now the step 3 will be calculate the molar mass. So now let's see how to do this. So the first step was to calculate the molality of toluene. The freezing point depression is given. So put that in and then get the molality. And we get the molality of toluene equal to 0.488 molar. Then put it into the molality equation. molality equals moles of toluene divided by the mass of the solvent, and I get the moles of toluene as 0.415 mole. Now let's calculate the molar mass, and we know the formula for molar mass is grams over moles. So from the grams and the moles, I can get the molar mass of toluene, that's equal to 92 grams per mole. We will do one more question on freezing point depression. The question is, calculate the volume of methanol that should be added to 655 milliliter of water that causes a freezing point depression of negative 25 degrees Celsius. Density of methanol and the Kf of water are given. So again, we have one formula that is a freezing point depression formula. We will use the same thing, and then the first thing we will do will be to calculate the molality of the solution. Once I calculate the molality of the solution, the second step should be to calculate the moles of methanol, the solute, because we know molality equals moles over mass of solvent. After we calculate the moles of methanol, we can get the grams of methanol using the formula, the relation between moles and grams and molar mass. So density is given, and hence the grams can be converted into volume, giving me the final answer. So now since we know the steps involved, let's do the calculation. So the first one is calculate the molality, and I get the molality as 13.4 molar. And to calculate the moles, we have the mass of water, convert that into kilograms, and I get the moles as 8.80. And then afterwards calculate the grams using the molar mass, and then use the density to calculate the volume.